February 1943. A new American fighter rose out of Guadalcanal with the confidence of a machine that looked impossible to beat. Bent wings, a 13-foot propeller, a 2,000 horsepower engine that shook the dirt under the runway. The Marines had been told this was the answer. 18 minutes later, the answer was burning in pieces over the Solomon Sea. The aircraft was the F4U Corsair, the fastest single-engine fighter America had ever sent into combat. And on its first day in the Pacific, it did not look like a weapon. It looked like a mistake. Japanese Zero pilots had pulled it into the fight they understood best. Slow, tight, turning, patient, lethal. The Corsair was faster. The Corsair was stronger. The Corsair could dive harder than almost anything in the theater. But none of that mattered once its pilots tried to fight the Zero the way the Zero had been built to fight. At low speed in a turning circle, the Corsair was not a miracle. It was a heavy airplane with a long nose, a violent engine, and young pilots who were learning in public. And the public was the sky. That is the part the legend usually skips. The Corsair did not become feared because the aircraft suddenly changed. It became feared because a handful of men stopped asking what the airplane was supposed to be and started asking what it actually was. One of them was not a famous commander. He was not a strategist. He was a former enlisted mechanic from New York named Kenneth Walsh. He had joined the Marines as a teenager, not to wear goggles and silk scarves, but to work on machines. Before he was an ace, he was the man under the cowling. Grease on his hands, oil in his sleeves. The engine not as a symbol, but as a set of facts. And after the Valentine's Day disaster, Walsh looked at the Corsair the way a mechanic looks at a bad sound in an engine. Not with embarrassment, with attention. The question was not, why did the Corsair fail? The question was colder than that. Where was the Corsair being wasted? The manuals could tell pilots its maximum speed. The briefings could say it was superior, but Walsh had watched what happened when that superiority was spent in the wrong currency. A Zero did not need horsepower if the fight became a circle. A Zero did not need armor if nobody could hit it. A Zero did not need to dive away if the American pilot was foolish enough to stay slow. So Walsh reduced the problem to the one thing the Corsair had in brutal abundance. Energy, speed, altitude, weight falling through air. Power turning into distance before the enemy could answer. The Corsair was not supposed to dance with the Zero. It was supposed to strike it like a falling engine block. Climb above them, dive through them, fire once. Keep going. Do not turn back. Do not get emotional. Do not reward the enemy by fighting his war. Use the dive to climb again, reset, attack from height, again and again. Later, people would give it a clean name, boom and zoom. In those first weeks, it was less a doctrine than a refusal. A refusal to pretend courage meant staying in a losing turn. A refusal to treat the Zero's strength as the place where American pride had to prove itself. Walsh was saying something that sounded almost insulting to fighter pilots. The bravest thing you can do in this airplane is leave the fight before the enemy gets the fight he wants. That was not how men liked to talk about air combat. Fighter pilots were taught to stay with the enemy, support their section, press the attack, finish what they started. Walsh was telling them to break the shape of the fight. One pass. One burst, one climb, one reset. It sounded like quitting between victories. But the numbers did not care how it sounded. On April 1st, 1943, Walsh took the Corsair into combat over the Russell Islands. This time, he did not ask the aircraft to be a better Zero. He let it be itself. He came down fast enough that the Japanese pilot did not get a duel. He got a flash, a burst from 650 caliber machine guns. A bent-wing shadow already climbing away by the time the wreckage understood what had happened. Walsh claimed his first victories that spring. By May, he had become the first Corsair ace. By late summer, he had proved the airplane could do the thing its debut had denied. It could dominate, but what Walsh proved was more important than a personal score. He proved the first manual was not enough. A machine can have the right power, the right structure, the right gun package, and still fail if the people using it have the wrong mental model. The Corsair had been introduced as a superior fighter. Walsh made it a specific fighter. That difference changed the Pacific. The Zero had been designed around one beautiful obsession: turn tighter than the enemy. To achieve that, Japanese designers cut weight everywhere they could. Less armor. No self-sealing fuel tanks in early models. A light frame that gave extraordinary agility and punished damage. In 1941 and 1942, that trade looked brilliant. Japan's naval aviators were some of the best-trained fighter pilots in the world. They had hundreds of hours. Formation discipline, gunnery skill, a fighting culture that treated the aircraft almost like an extension of the body. Against early Allied pilots, the Zero looked like a perfect weapon. But perfection is dangerous when it teaches an institution to stop listening. Because every perfect weapon has a bill hidden inside it. The Zero's bill came due at high speed. At 350 miles an hour and above, the controls could stiffen. The aircraft did not like violent dives. It could not absorb punishment the way heavier American fighters could. And once American pilots stopped turning with it, the Zero began to look less like a sword and more like a blade without a shield. The Corsair's bill was different. It was hard to land on carriers. Its long nose blocked forward view on approach. Its landing gear bounced. Its early deck trials made the Navy nervous enough to push the aircraft away from the carriers it had been designed to serve. So the Marines got it. Land bases, rough strips, volcanic dust, hot engines, short sleep. It was an awkward solution. And sometimes awkward solutions win wars because nobody has polished them enough to make them useless. By the end of 1943, Corsair pilots were no longer trying to prove the aircraft was elegant. They were proving it was unfair. A Zero could not force Corsair to stay. That was the new terror. The bent-winged fighter chose the angle, chose the speed, chose the moment, chose whether the fight existed at all. And once that lesson moved from Walsh's hands into squadron habit, the air war began to tilt, not instantly, not cleanly. Men still died. Aircraft still came home full of holes. But the pattern had changed. The Corsair was no longer a promise. It was becoming a method. Then a second problem appeared. The airplane could win a fight it could reach. But the Pacific was not a battlefield. It was distance pretending to be water. Rabaul, the great Japanese base on New Britain, sat behind miles of ocean, airfields, warning networks, weather, fuel limits, and fatigue. A fighter that ran out of fuel before it reached the war was not a fighter. It was a very expensive engine practicing optimism. So the Corsair needed a second transformation, not in the gun sight, in the throttle hand. And the man who helped force that transformation was the most politically inconvenient civilian in the American war effort, Charles Lindbergh, the same man who had crossed the Atlantic alone in 1927, the same man whose pre-war politics had made him toxic to many Americans. In 1944, he arrived in the Pacific as a technical representative, Not a uniformed commander, no rank that mattered, no authority to order combat pilots around, only flight experience, engine data, and a willingness to make trained men feel uncomfortable. Lindbergh studied what pilots were doing in cruise, how they set mixture, how they managed revolutions per minute, how they used manifold pressure, how much fuel they burned before they ever saw the target. And what he found was not heroic. It was waste. Not cowardice, not stupidity. Waste. Pilots were flying powerful engines as if every minute were combat. The Corsair could be handled more carefully before the fight and still unleash everything when the fight began. The airplane did not need to shout all the way to the target. It could whisper until it was time to kill. That sounds simple from a desk. It was not simple in 1944, when a pilot over open water trusted engine noise the way a sailor trusts horizon. Leaning an engine too far could kill it. Running settings that felt wrong could feel like gambling with your own funeral. But Lindbergh had numbers. Test flights, fuel logs, engine behavior. The stubborn patience of a man who knew that an argument with a fuel gauge can be won only by letting the gauge speak. The result was another uncomfortable truth. The official idea of what these aircraft could do was smaller than the aircraft itself. With careful fuel management, Marine and Army pilots could stretch range, loiter time, and payload expectations. Targets that Japanese planners treated as safe began to hear American engines. Airfields that had arranged their defense around known American limits discovered that the limits had moved. No new miracle engine had arrived. No secret weapon had been installed. The same machines were flying farther because the men inside them had learned a quieter kind of aggression. This was the second half of the Corsair story. Walsh taught pilots not to waste speed. Lindbergh taught them not to waste fuel. One changed the shape of the fight. The other changed the size of the map. That combination turned the Corsair from an aircraft into a system. Altitude, dive speed, heavy firepower, a rugged airframe, better range discipline, more pilots learning the same method, more mechanics keeping the machines alive, more factories sending parts, engines, and replacements across an ocean. Japan had opened the war with pilots who were almost irreplaceable. America answered with a machine that became more dangerous as ordinary people learned how to improve it. Mechanics, junior pilots, test pilots, technical civilians, squadron officers willing eventually to let evidence insult tradition. That was the real asymmetry. Not spirit against machinery, a closed system against a learning one. By 1944, the Zero was still deadly in the right hands, but there were fewer right hands. The veteran Japanese pilots who had made the aircraft terrifying in 1941 were dead, wounded, exhausted, or spread too thin across a collapsing perimeter. Replacement pilots arrived with far fewer hours. Some had courage, some had discipline, some had no realistic chance. A fighter aircraft is not just aluminum and gasoline. It is training time made visible. And Japan was running out of time faster than it was running out of aircraft. Then the war changed again. On October 25, 1944, off Samar, a Japanese pilot drove his aircraft into the escort carrier USS St. Lo. The ship exploded from within and sank. The kamikaze campaign had begun. And suddenly, boom and zoom was not enough. A Zero flown by a pilot trying to survive could be frightened, baited, outmaneuvered, denied the fight it wanted. A Zero flown by a pilot who had already accepted death was another problem entirely. It did not need to win the air battle. It needed to reach a ship once. That single change attacked the deepest assumption in fighter combat. Normally, survival is part of the enemy's calculation. Now it was gone. The attacker did not need to disengage, did not need to conserve, did not need to turn away when the odds collapsed. He only had to keep the nose pointed at steel. For Corsair pilots, that meant the standard for victory became almost impossible. 90% interception could still be disaster. One aircraft getting through could burn a destroyer. 3 could change a morning into a mass casualty report. Off Okinawa in 1945, the Corsair's earlier lessons converged under the worst possible pressure. The aircraft needed speed to intercept, range to remain on station, firepower to break incoming attackers quickly, durability to keep flying after shrapnel and machine gun hits, and pilots trained not merely to chase aircraft, but to solve geometry while exhausted. Where is the attacker? What is his line? How long until he reaches the fleet? Can I kill him on this pass, or do I need to position another pilot? The fight had become less like dueling swordsmen, and more like trying to catch falling glass before it hit the floor. During the Kikusui attacks around Okinawa, Japanese aircraft came in waves. Some high, some low, some mixed with decoys, some obsolete types loaded for one-way flight. Corsairs and Hellcats rose to meet them, not as glamorous hunters but as a moving wall. And the cruelty of the numbers was this: they could perform brilliantly and still watch ships burn. That is what makes the Okinawa air defense story so different from the legend of the ace. It was not about one man becoming famous. It was about a system absorbing terror and continuing to function. A pilot could shoot down 3 aircraft in a morning and still remember the one smoke trail that got past him. A squadron could claim victory and still hear the names of dead sailors by sunset. The Corsair did not make kamikaze warfare harmless. Nothing did. But it gave the fleet a fighting chance at a scale few aircraft could have sustained. The same machine that had been humiliated in 1943 was now part of the air shield around the largest naval campaign in the Pacific. That transformation took 2 years. 2 years of combat reports, 2 years of engine failures, 2 years of pilots dying when a lesson arrived too late, 2 years of mechanics keeping bent-wing fighters flying on island strips that looked less like airfields than wounds in the jungle. And by the end, the aircraft had become something no designer could have finished on a drawing board. It had become experience in metal form. After the war, the Corsair did not disappear. It flew in Korea. It hauled bombs and rockets into close air support missions that its early carrier trials had never imagined. It stayed useful long after many wartime fighters became museum pieces. More than 12,000 were built. Its engine family helped power the piston age of post-war aviation. Its lessons moved into training, operations, fuel discipline, and the quiet culture of pilots who understand that the manual is not the aircraft. Walsh, the mechanic who became the Corsair's first ace, lived long enough to see the legends settle around the machine. He retired from the Marine Corps as a lieutenant colonel. He did not become the sort of celebrity the public knows by instinct, but his real legacy was never a poster. It was a habit of thought. Ask what the machine can do. Ask what it cannot do. Do not confuse bravery with using it badly. And when the evidence humiliates your doctrine, keep the evidence. Change the doctrine. That lesson reached beyond the Corsair. It reached into the defeated side as well. Japan rebuilt after the war by studying systems, process, manufacturing discipline, and quality control with a seriousness that would reshape the world economy. The country that had spent its finest pilots faster than it could replace them became, in peace, one of the great industrial learning cultures of the 20th century. That is the strange afterlife of the Corsair and the Zero. The Zero was a brilliant answer to one set of constraints. The Corsair became a brutal answer to another. But the deeper victory was not that one airplane was beautiful and the other was tougher. The deeper victory was that one system learned faster while the war was still being fought, because somewhere between the Valentine's Day disaster and Okinawa, the Corsair stopped being an embarrassed new fighter with bent wings. It became a question that every successful institution has to survive. Can you hear the mechanic before the machine fails again? Can you let a junior pilot prove the manual incomplete? Can you admit that the enemy has found your weakness before pride turns that weakness into a graveyard? The answer in the Pacific was written in engine oil, fuel logs, combat reports, and wreckage. The aircraft that failed when it tried to fight like someone else won when people finally let it fight like itself. The Corsair did not become Whistling Death because it was perfect. It became Whistling Death because imperfect people listened carefully enough to make it honest. And in war, honesty learned fast enough can sound exactly like a dive whistle.